Okay, jumping back up to an earlier slide now, slide 7. We've just looked at authentication and authorization. Let's take a look now at encryption. So let's go back down through the slides, down past 12 here. There we go. Data encryption. So encryption is what it sounds like, right? It's encrypting so that only people who are in the know, who have the right password, for example, can access information. So if somebody's listening into the conversation, which if it's wireless, they can easily do through what we call a protocol analyzer, such as Wireshark, for example. And if they're plugged in, they can also use Wireshark, but they can actually look at the packets and the content of the packets. But if it's encrypted, it's going to be meaningless data to them. Data can also be secured with encryption to prevent someone who has gained physical access to a computer. So let's say now that they have access to the computer, unless they know your password or the password to unencrypt it, to decrypt it, then they are not going to be able to read the information on it. The most widely used method, now notice this says method, not algorithm, for encrypting data is IPsec. Now IPsec is really it's a conglomeration of things. In other words, it has built into it, you choose what kind of authentication I want to use and what kind of encryption I want to use. So you have to choose those, and the two computers have to agree on that in their IPsec configurations before they can transfer data. Within that, we have several algorithms for encryption. So for example, the most popular one is AES. So AES is actually the government's standard encryption algorithm. Another one that's close behind it in usage would be DES. And then there's one called triple DES, 3DES. And then there's one called Blowfish and one called Twofish. I would say those are probably the 5 most used encryption schemes. And any one of those, well, not any one of them, actually AES and DES are the two that you can choose from in IPsec when you set up IPsec. An association is formed by two devices authenticating their identities via pre-shared key, Kerberos, or digital certificates. Now, if they're talking through a Windows domain, we've already mentioned that Kerberos is what they use. Pre-shared keys are often used, for example, in Wi-Fi. So I have I put my password, I program my password into my wireless router, and then I program that same password into my computer. That's a pre-shared key, and they both have to have that key in order to communicate. Digital certificates is another way to do it, and this is used quite often when we're moving data from one place to another. For example, across the internet, we often use digital certificates. This uses a third-party system. Well, let me see. I think we actually talk about that here. So let me switch over here. Pre-shared keys, series of letters or numbers or special characters that you put on two different devices. Kerberos is within the operating system most typically, and it's all the operating system generates the keys as it goes. And now digital certificates uses a third-party system to distribute what we call the public key. Now, in order to understand this, you have to understand a little bit about how these keys work. This is different from a pre-shared key. The pre-shared key is using the same key. We call this symmetric encryption, and it's using the same key for both computers. For example, if my password for my Wi-Fi is banana, then I have to type banana into my computer in order for them to talk to each other. That is called symmetric encryption, and they use the same key on both sides. However, with digital certificates, we don't use what we call a symmetric key. We use what we call an asymmetric key. Now, an asymmetric key has both a private key and a public key, and they're a pair. If I encrypt with the private key, I can decrypt with the public key. If I encrypt with the public key, I can decrypt with the private key. Typically, the public key is public knowledge, and the private key I keep privately. So, for example, if I want to send you an encrypted message, I send you the message, and I send you the public, I encrypt it with the public key, with your public key. You get it, and then you decrypt it with your private key. That way, no keys ever have to pass across the network. So it's a two-key system. Well, digital certificates work by a third-party company keeping track of your private and your public key and dishing out your public key when it's needed to another party. So if I want to send you an encrypted message, I need your public key first. So I get that through a digital certificate that is sent to me through a third-party company. So that's how digital certificates work in very broad and general terms. If someone gains access to your hard drive, when data is stored on it, the data could be vulnerable. Okay, that makes sense. If somebody has access to your hard drive, let's say that you are a salesman and you have a laptop and you're out in the field with your laptop. If somebody has physical access to that, they steal your laptop, they would have access to all the data on that hard drive. But if it's encrypted, then of course they can't get into it unless they know your password, because most of these encryption systems use your logon password as the key for unencrypting or de-encrypting that data. So we have a couple of different systems on Windows in order to encrypt that information. One is called EFS, or Encrypting File System. And we can demonstrate that very quickly and easily. I'm just going to go to my documents here. I'm going to right-click on anything. I'll right-click on this folder right here. Go down to Properties and go to the General tab and then down to Advanced. And here you see Encrypt Contents to Secure Data. This is EFS, Encrypted File System. So I can simply turn that on and that becomes encrypted. Now nobody else can read that on my hard drive unless they know my logon. Another system we have available to us if we have a Windows Pro system, for example. We can't do this with a Windows Home computer, but we also have something called BitLocker. And by the way, EFS is designed for encrypting a folder or a file. BitLocker is designed for encrypting an entire drive. So the C drive, the D drive, and so on. There's also a version called BitLocker to Go that can lock down mobile devices, such as, for example, a USB stick. So if I have a thumb drive, I can now encrypt that. Now I have a thumb drive that I carry in my computer case with me that has some information that I might need. So, for example, the information that I need in order to log on to my home machines. I have that information on a text file on that drive. But I have BitLocker to Go turned on so that I have to know the password in order to open up that drive and read that information. So BitLocker is for whole drive encryption. EFS is for file and folder encryption. And that ends our data encryption section.